Hi guys, following our conversation about how to do the mesh modifications and morphing that is generated inside the diameter. So we are right now at Gold Star account. This is two objects that we were talking about, and let me show you how to do the adjustments to it. So I already went ahead into each one of them and clicked open the model and downloaded it. So I have these two models, ring and hat. So let's go ahead and open the Rhino. So we bring in Rhino. Let's try to do the hat first. And we're just importing this mesh into the Rhino. And our goal today, is just to remind, is to how to do the morphing and adjustments to the mesh. So yes, mesh in diameter is that when it's generated, it's pretty dense, and you see it's all like a black. And the reason for this is because there are a lot of details and vertices. So for optimization of the performance of Rhino, we can do a few steps to optimize the mesh. So we can actually select this first, and we can go to the mesh tools, and then we can do a shrink wrap. So the shrink wrap is basically reducing the number of vertices, smoothing the surfaces, optimizing the whole perspective. So we need to do, if we'll click here preview, we will see how the adjustments are happening on our piece. And usually we can do hide the input objects, and you can see that shrink wrap is actually created, but it has a little bit too, the details are lost in two severe ways, right? So actually it's very easy to bump up here the optimization. So we can do 0.1 and see immediately the updates of the optimizing of the mesh. It looks already pretty good. We can maybe bump it up a little bit more. The good thing to look at is here there is a face count, and you can see whenever we're changing the parameter of the edge length, the mesh optimization happens automatically. And when you see that details are correct and it's not missing or losing specific parts, that means you found the right edge. It depends on the piece. Sometimes the pieces are more smoothened and you want them to be smooth. Then you can make this value a little bit higher. But if it's a lot of corners and details and intricate pieces, you can make it smaller. So now we can actually delete the input object that we were shrink wrapping and just click apply. And now we're left with the hat that is mesh optimized. We have less polygons, easier to operate, easier to work inside the viewport, but we can actually do one more. Remember, we had around 20,000 of faces, but we can make it even better. We can make this mesh even better with Rhino. So we can go to another tool, which is called Quad Mesh, and we can say that the target count is 2,000 of the polygons. So we go in here and we're saying, let's do the preview, and we can hide the input object, and we can even the delete input object later. So you can see the difference between the Quad Mesh. It's basically doing the optimization. That's how it was before. That's how it's now. And the preview is giving you this optimization parameters. And you can actually see that also here we already went from 20,000 polygons to 4,000 faces. We can increase here the value of how many different polygons we're trying to, for it to target. The higher it is the density, and you see the face count is increasing. It's again, it depends on the intricate details of the piece. And if it's a smooth like this hat, you can go pretty aggressively up to 2,000. It will be pretty okay for this, and you can see how it looks. You just spin around, see does the details are being lost or not. So, and as soon as you're happy with this, you can just click apply. Once you're happy with this, now we're ready. Actually, after we have optimized the mesh, we are ready for performing the morphing of this mesh. So for this, we will need a command which is called cage edit. You can type in here, or you can call the cage edit from the tools. I just, for simplicity, we can go to the cage edit. So in here, it will ask us how we're going to be constructing this cage. So we can say we want to construct a bounding box. We want to do C-plane. And now if you see, we have this XYZ axis around this hat that are spinning. And basically it says for how many slices we want to slice Y, how many slices X, and how many slices Z. You can just put here a number of the slicing. You see it's automatically updating. Degrees are fine, keep them as 3, but you can just say, okay, I want to do 5s. It's a matter of just a little bit experimenting. Maybe sometimes for the y-axis I might need maybe a little bit less. I can have 4 and 5. Experiment and you will see. You will see in a second what these slices actually mean. It basically shows on how many slices on each axis it will be cut into the pieces. As soon as you're happy with this, you click done, and you can do global or local. If you have multiple pieces, it will be global, but we're right now working only with this one piece. And we can say done, and now you see we have a control points for the mesh to perform any mutations within this confined box. So, and now all what's left is actually to start selecting these control points and pulling them any direction you want. So let's imagine, you remember one of the comments, we want this to be flatter, or maybe the whole piece to be a little bit more flatter so that this will not be bulging here. So it's as easy as just selecting these pieces, and we can just go from the perspective to the side view, and let's do the top. So we're here, it's upside down. I can just actually rotate it later or in the beginning, but all what I will need is just to drag and drop this piece, and you can see how the whole piece is morphing any direction that we would like to it to go. We can sit in the perspective. Sometimes I like in the perspective because you can view where to go. So if I'll grab some of the pieces here, I can just drag and drop them into another position, and it will be just as effective as doing it from the front position. So here I can just maybe do even more flatter this part. I can just go here and position it and start even more flattening it the direction I want. And we can go as much as we want, or stretch, or do any modification to this piece. And you can see that from the front perspective, whenever the customer is seeing this, it's gonna be identical, right? So they will not see a difference. While on the back side, it's pretty flat. We can actually bulge more from here. Also, if we want to have create a setting here, we can bring here a cylinder and do the Boolean operation of cutting out the specific setting here, or even the prongs. If we want to scoop out this metal from the bottom part, we also can put here cylinders and other parts to perform the Boolean operations. But I would highly recommend, before going here, try to squeeze as much as possible value from diameter itself by generating those pieces as much as you can. And then it will be much, much easier to do it here in the Rhino, this adjustment. This sums up. Let me know if you're interested how to do this inside, for example, Blender. I can show you the same operations. Actually, Blender gives you a little bit more even control for the meshes. So we can just, for example, say that this is our perspective is done. So now let's do File, Save, and I will show you how to do. This is Blender 1. This is Rhino 1. Let's save it. And let's go to the Blender and see how to do it in Blender. So if we go to Blender, this is, it's saved as a 3DM. It's either way, we can just export this as STL. File, export 3DM, STL, geometry, and we'll do this. And let's save it as STL. So we are exporting binary export open objects. So we're exporting. Now we're back to the Blender, and we have R1 STL, right? And if we bringing it inside the Blender, we're importing the piece. We can do again all the gimbal. We can do the rotation or anything that we want with this piece. But I wanted to show you the actual morphing of the polygons for this piece in Blender. So we can rotate it any way we want, obviously. Same we could do inside the Rhino. But if we're having this piece here, right, and we are ready to do the morphing. In Blender, it's happening a little bit different way. we need to come here, add, and say add lattice deform selected. You can see it's actually very similar to what we have in the Rhino, right? So it's applying a cage around it, and now in a Blender, if you come here, you can say how many, what is the resolution, right? If you'll say what is my, and you remember those slices that we saw in the Rhino, these are the slices. That's why I like a little bit more Blender, because you can visually see, okay, what would be my density of the control points, and you can just increase them as much as you want. And by the way, you can change them afterwards. In Rhino, I believe you cannot do this after you applied. But here we have this cage and we have control slices, and in their intersections will be a control points. So at this moment, we're going to the edit mode, and here we go. We have the same similar control points as we had inside Rhino, but here what I like is you can just easily navigate to the different positions, and you can a little bit maybe easier control those points and just smoothen it up, or if you want to stretch certain things, a little bit of sculpting, right? So we're not dealing with the parametric systems. We are dealing with sculpting and a little bit more artistic visualization of this piece, right? So if we want to do it a little bit more flat and collapsed over here, so that's what we can do here. The same will be applied, right? It's not only the back side. You can actually control any point. So if at some point we decided that this piece needs to be larger, that's very easy to do morphing and modification either way, whether it's going to be Rhino or is it going to be Blender. We can do either way. What I like in Blender is also you can have a control of your brush. So if we saying that we're going to be moving this, so you can make a brush and do the modification. Is it more fine-tuned morphing or movements, or if it's a much bigger? So if we, for example, saying that I want to take only these pieces, you can see that that's how it's moving. But if I will increase the brush, it's start touching the bigger areas. But if we don't want bigger areas to be impacted, we can just reduce the brush size. It's a little bit similar how ZBrush is actually operating with the mesh controls, and that's how it works. I hope it makes sense to you guys. And again, to create a setting, we need to bring some cylinders and perform a Boolean operation on the mesh with a specific sizing of the cylinder. If we want to do the cutouts here to reduce the amount of metal, we can do the same thing with the Boolean operations. But ultimately, I hope you guys getting the concept of how to do the mesh modifications in either software, whether it's Rhino or if it's a Blender. It's pretty straightforward. Please let me know if you have any questions or comments. I would be happy to hop on the call and go through some of the cases that you have on your hands. Thank you. Have a great day.